transistor or MOSFET or IGBT or thyristor, SCR or GTO, whatever it is. I have seen only simply it is a black box, right? So first I will talk about the ideal switch. So in ideal switch, when it is on, the drop across the switch, or you take Vs, the drop across the switch, drop across switch 0. What about the current? Current is a large. So what is the power dissipation? What is the power dissipation? Power dissipation is nothing but Vs into Is. Of course the current may be large, but this is 0. So finally you will get 0 watts. So that's why I consider in all the converters input power equal to output power, because this is the only one which is consuming the power. Since I have taken all the ideal switches, so you can take it as a dissipation equal to 0. Okay. When it is off, Vs equal to large and Is equal to 0. So what is the power dissipation? Vs into Is. So this is anyway 0, so 0 watts. So this is for ideal switches, right? Now we'll see the actual switches. So before going to the actual switches, I will just plot the input and output and the power loss, whatever I have written in this equation. This is the power dissipation. This is the current. So initially the switch is on. So when the switch is on, the voltage is 0 and the current is some value. So this voltage is 0. When the switch is off, the voltage, of course, it may be negative. So you can take positive. So voltage is like this. So when the switch is off, the current is 0. So this is a on period, this is off. I am talking about ideal switch, right? So if you see the time here, the turn on time, what is the time on? See, here is on and here is off. So what is the on time here? On time equal to 0. Very fractional, very abrupt. Within a 0 seconds it is reached. So for ideal switch, turn on time equal to 0. But what about the turn off? So this is, here is off and here is on. So this is the time. How much duration? Very fraction of time. So P of is also 0. So for ideal switch, T on is 0, T off is also 0. What about the power dissipation? So power dissipation is nothing but V into I. So here also 0 because this is 0. Here also 0 because here voltage is 0, here current is 0. So there is no power. Power is 0. No power dissipation. Right? Now I will come to the actual switches. So actual switches, broadly they have divided into 3 types. So one is uncontrolled switches or semiconductor devices, and the second in semi-controlled, and the third is fully controlled. Uncontrolled means based on
So what was given?
voltage,
The given is V1 is given,
comma, current.
which is 1 into 10 power 5 into 100 square,
The switch
and V2 is given
may on
32.34 bar,
or off. This is not in your hand. Based on the voltage and current in the given circuit. You don't know given circuit configuration. So uncontrolled switch means based on the output, based on the voltage and the current in a given circuit, based on voltage and current across the switch.
then I add RC4 down,
I'll repeat once again. Based on voltage and current across the switch in a given circuit, the switch may be on or off. Nothing is in our hand. What is the example for this? We have already seen. What is the example for this switch? Uncontrolled switch. Diode. The example is diode. Okay. Next, semi-controlled switches. So that means not fully controlled. That means either on or off is possible.
what is the
Not both.
V1 in the process?
That means I may have a control over the switch just to switch on. Whenever I want to switch on, I will switch on. But once switch on, I cannot control it. I cannot switch off button. Or in some cases, I can switch off whenever I want to switch off, but I cannot switch on whenever I want to switch on. So that kind of switches, either on or off is possible, not both. So what is the example for this? Example for the semi-controlled switches. Anybody? Thyristor, then example, thyristor only one switch. Actually, strictly speaking, thyristor is not the name of the switch. It is the name of family of the switches. So example is so what else? Thyristor family will come. What else will come? SCR. So many are there, na? Etc. Because there are so many are there, we will discuss all those things. Okay? SCR and I forgot. GTO is there and so many are there here. So thyristor family. What about the fully controlled? Can make switch on or off. Completely controlled. So what is the example for this? So if I want to on, I will on. If I want to off, I will off.